What is the value of 2 plus 0 minus 1 times 6? In this question, they're really just concentrating on order of operations. You guys know BEDMAS, right? So for this one, first you do the multiplication, and then you do the addition and subtraction. So that's going to be 2 plus 0 minus 6, and then that'll just be minus 4. The average mean of 3, 5, 6, 8, and x is 7. What is the value of x? You would add these numbers, of course, and then divide by how many there are, which is 5, and that's going to be 7. So this looks to me like 22 plus x is 35, and therefore x is 13. For any real number, x bracket denotes the largest integer less than or equal to x. So for example, 4.2 bracket is 4, minus 5.4 bracket is minus 6. What is the value of minus 2.3 plus the bracket of 1.6 all bracket? Okay, so 1.6 bracket would be 1, right? So this basically becomes 2.3 plus 1 all under the bracket. So that's minus 1.3. And then we want the largest integer less than or equal to x. So I believe that's minus 2. A street magician has 3 cups labeled in order ABC that he has upside down on his table. He has a sequence of moves that he uses to scramble the 3 cups. He swaps the first and second, then he swaps the second and third, then he swaps the first and third. If he goes through this sequence of 3 moves, a total of 9 times, in what order will the cups be? Initially, it's ABC, right? And then the first, I guess, sequence of moves, he scrambles the first and the second. He swaps them, I guess. So that means it becomes BAC. And then he swaps the second and third, so it becomes BCA. And then he swaps the first and third, so it becomes ACB. Okay, so this is the first, I guess, series. The next series, go through the same thing, swap the first and second. Hold on, we ended at ACB, right? So the first swap is the first and the second. So it would be CAB. And then the next one is the second and the third. So it would be CBA. And then the last one is the first and the third. So it would be ABC. So we're right back to ABC. And that's after the second set of swaps. So it seems to me that after 2 of these, I guess, sets, we're back to ABC. So what are they asking for? 9 times. Okay. So after the third, it'll be ACB, just like how we have here. After the fourth, it will be ABC. After the fifth, it'll be ACB, meaning at the end of the 3 moves. After the sixth, it will be back to ABC. After the seventh, it will be ACB. After the eighth, it will be ABC. And then after the ninth, it will be ACB. So ACB is the answer to this question. A parabola has the equations y is equal to ax squared plus bx plus c and passes through the points minus 3, 50, minus 1 and 20, and 1 and 2. Determine the value of a plus b plus x. All right, well, I guess we just plug these guys into this equation and try to solve. So if I plug this guy, it will be 2 is equal to a times 1 squared plus b times 1 plus c, which is 2 is equal to a plus b plus c. And I think that's it. That's what they wanted you to figure out. So very straightforward here. The answer is 2. Yeah. For some positive integer m and n, 2 to the power of m minus 2 to the power of n is 1792. Determine the value of m squared and n squared. 2 to the power of m minus 2 to the power of n is 1792. Now 1792, is that a power of a 2? I don't think so. Okay, not a problem. We have to find two powers of 2 that when subtracted gives 1792. So you have to just list them, right? 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Okay, I think I've gone as high as I need to. I'm going to have to choose at least something greater than this guy. And what do I need to subtract to get 1792? I think 256 would do it. Yeah, I think 2048 minus 256 is 1792. So what was this in terms of a power? This was 2 to the power of, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically this was 2 to the power of 8. Oh, sorry, no. 2 to the power of 11 minus 2 to the power of 8 is 1792. So that means that m is my 11 and n is 8. N is 8. So n is 8. Okay, so therefore m squared plus n squared would be 11 squared plus 8 squared, which is 121 plus 64, and that is 185. A two-digit integer between 10 and 99 inclusive is chosen at random. Each possible integer is equally likely to be chosen. What is the probability that its tens digit is a multiple of its ones digit? So the n is inclusive, so everything from 10 to 99 inclusive. Okay? And the probability, well, most probability questions are a fraction, the numerator and the denominator. The denominator is the total, and the numerator is our specific condition. Specific condition. Now the total, let's see here, the total number of n's possible between 10 and 99 is 90. So that's what goes here. Now the specific condition, that's what we have to talk about here. Okay, so what is the specific condition that they're asking for? They want the tens digit to be a multiple of its units digit. Okay, so for example, if the tens digit is 1, the units digit would be 1. And that's the only way to get a multiple. Yeah. If the tens digit is 2, it could be 1, but it could also be 2. If the tens digit is 3, it could be 1 and 3, I believe. And so on. If tens digit is 4, it could be 1, 2, and 4. 5 would be 5 and 5. I think we just have to manually do this. 6, 1, 6, 2, 6, 3, and 6, 6. And then 7, 1, 7, 7. 8, 1, 8, 2, 8, 4, and 8, 8. And then 9, 1, 9, 3, and 9, 9. I think these are the only ones. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 goes there. And I think that's it. That's the probability. Rectangle ABC has an area of 2016. Point Z is inside the rectangle, and point H is on AB, so that ZH is perpendicular to AB. If ZH to CB is 4 to 7, what is the area of pentagon ADCBZ? ADCBZ looks to me like it's the area of the full rectangle minus that triangle ABZ. Okay, I think this should be all right. We're going to have to do a little bit of labeling, though. ZH to CB is 4 to 7, so I'm going to call that 4x, and therefore that's 7x. And then that one I'll just call y, the D to C part. So the A to B is also y. And I think that's it. So first of all, this is very important, this piece of information. So that's 2016, but what it represents really is y times 7x, I believe, the way I've labeled it. So that means that xy is 2016 divided by 7, which is 288. And hopefully that will come in handy later on. So ABZ, that's 1/2 base times height, which is y times 4x. So this is 2016 minus 2xy. And yeah, there you go. That's where that comes in. So it would be 2016 minus 2 times 288. And therefore that's 2016 minus, well, this whole thing, if you crunch it out in numbers, is 1440. Yeah. And that's the answer. Suppose that A and B are digits with AAA plus AAB plus ABB plus BBB is 1503. What is the value of A to the power 3 plus B to the power 3? So this looks like a whole bunch of trial and error, and, I'll let you do the trial and error. You have to say, okay, let's see what happens if A is 1 or if A is 2 and things like that. So when you do the trial and error, let's start with that column. So it would be A plus 3B is equal to 3. Now, it doesn't necessarily have to equal 3, right? It could equal 13, and you could carry the 1. Or it could equal 23, and you can carry the 2, right? So there's obviously some trial and error here. This is the right one, by the way. Save us some time. And you get that when A is 2 and B is 7, right? So that pretty much means that this would be carry the 2, and then this would be, let's see here, 2 plus 2 plus 2 is 6. 6 plus 7 plus 7 is 20. So then you carry the 2 again. And then that's 2 plus 2 plus 2 plus 2, which is 8. 8 plus 7 is 15, and that's how you get the 15. So you obviously would have to do probably some trial and error. You'd experiment with this guy, experiment with this guy. So it's a little time consuming. And then to this, be careful though, because this is 3 and this is 2. A little bit of a room there for error. So this would be 2 to the power 3 plus 7 to the power of 2. So that's basically 8 plus 49, and that is 57. 57 is the answer. Clara takes 2 hours to ride her bicycle from Apsley to Bancroft. The reverse trip takes her 2 hours and 15 minutes. If she travels downhill at 24 kilometers an hour, on a level road at 16 kilometers an hour, and uphill at 12, what is the distance in kilometers between the two towns? Let's draw a little diagram. And we've got Apsley and Bancroft. And I have no idea what are the distances, so I'm just going to label them X, Y, and Z. And I'm going to call this one downhill, and this one flat, and this one uphill. And it all balances out since she's going back in the other direction. So kind of the same way. And then let's see here. We're obviously going to use that formula, speed is equal to distance over time, or any such variation, which would be, let's think about this. Time would be equal to distance over speed, like that kind of thing. Okay, I think this one is probably the one we'll use. Time is equal to distance over speed. So let's just proceed with that. So the first segment of her journey is, let's see here, 2 hours, right? So that's when she's going from A to B. So 2 hours is the time, and each segment would have its own individual time. So this first segment would be the distance, using that formula right here, the distance over speed. So she's going downhill at 24. And then distance over speed, y over flat, is 16, I believe, right? And then the uphill, z, is 12. Okay, and then the next part is 2 hours and 15 minutes. So in terms of hours, that'd be 225. And this is going to be, okay, so if she's going that way, this is the uphill now, and this is still the flat, but then this is the downhill, so you got to be careful because she's going in the opposite direction, right? So then that's going to be x over 12 plus y over 16 plus z over 24. Okay, so that's the math. And off we go. So what are we trying to find here? The distance between the towns. So the distance is x plus y plus z. That's what we're trying to find. And we've got these two equations. All right, let's see here. What do we do? Well, let's will we add them? If we add them, maybe. If I add them, I get 4.25. And then we get a common denominator. X plus 2x over 24. And 2y over 16. And then 2z plus z over 24. I just made the common denominator. So that's 3x over 24. This is y plus y over 8 plus 3z over 24. So that's x over 8 plus y over 8 plus z over 8. Okay, that's good. And then I can just multiply through by 8. And when I do, I get x plus y plus z. And the 4.25 times 8 is 34. So there you go. That's the answer. 34. And I believe it would be kilometers. The first and second terms of a sequence are 4 and 5 respectively. Each term after the second is determined by increasing the previous term by 1 and dividing the result by the term before that. For example, the third term equals 5 plus 1 divided by 4. What is the 1, 2, 3, 4th term of the sequence? So I think we will have to do some sort of a extrapolation, hope that there's some pattern. So let's see, let's just, I don't know, put 15 terms and let's see if there's some pattern. Okay, first term is 4. That's what they give you, and the second term is 5. So those two are given. The next term, they actually tell me how to do it. You add 1 and divide by the previous. So it'll be 5 plus 1 divided by 4, and that is actually 1.5. So obviously we're not getting integers every time. The fourth one, you take the 1.5, add the previous term. Oh no, you add 1. Hold on, always adding 1. Okay, add 1, and then divide by the previous. So in this case, you divide by 5. And that comes to 0.5. Okay, let's keep going here. 0.5 plus 1 divided by 1.5 this time. And that looks like 1. And then the sixth term, 1 plus 1, and then divided by 0.5, because you have to divide by the previous term, which is this guy. So that looks like 4. Okay, and then 4 plus 1 divided by this guy, which is 5. Okay, so we're back to 4, 5. So then there would be 1.5, 0.5, 1, and so on. And then 4, 5. Okay, so that basically means that this pattern repeats every 5. So that's pretty straightforward. So it looks like every multiple of 5 will be 1, like that. Oh, I didn't even, where's the 14? Didn't even put the 14 in. So this 13 would be 1.5, this would be 0.5, and the 15th term would be 1. Okay, no problem. So every multiple of 5, so if we're getting sufficiently close to 1, 2, 3, 4th term, 1, 2, 3, 3, 1, 2, 3, 2, 1, 2, 3, 1, 1, 2, 3, 0. This guy is going to be a 1, since it's a multiple of 5, 1, 2, 3, 0. So then you can just continue with the pattern. This will be 4, this will be 5, this will be 1.5, and this will be 0.5. So 0.5 is the answer to this question. Austin and Joshua play a game. Austin chooses a random number equal to 1, 2, 3, 4, or 5. Joshua then chooses randomly from the remaining 4 numbers. Joshua's first round score is equal to the product of his number and Austin's number. Austin then chooses randomly from the remaining 3 numbers, and his first round score is the product of his second number and Joshua's first number. The process is repeated until each of the 5 numbers has been chosen. The sum of each player's 2 scores is the final score, and the player with the highest final score wins. If Austin chooses 2 to start, then Joshua chooses 3. What is the probability that Austin will win? Well, let's do a little bit of an example first. So we're starting off with these 5 numbers, and Austin. I'm just gonna choose something at random. I want to illustrate this. So let's say he chooses 3, and then Joshua chooses 4, right? So the score is the sum of the previous 2, right? This process is repeated. The sum of each player's 2 scores is the final score, and the first round score is the product of his second number and Joshua's first number. So the score here would be 3 times 4, which is 12. So score, I guess. And then we can only select, I guess, what hasn't been selected yet. Yeah, because the remaining 4 numbers. Yeah, so whatever is remaining. So let's just say he chooses 1. Now the score is the product of his and the previous, so it'd be 1 times 4, which is 4. And then Joshua selects, let's say, the 2. So his score is 2 times 1, which is 2. And then finally, Austin chooses the only number remaining, which is 5, which then makes that score 5 times 2, which is 10. So the total score, or final score, is whatever they're calling it, the final score. For Austin, it looks like that 4 and that 10, so that's 14. And then for Joshua, it's this 12 and that 2, which is also 14. Okay, interestingly, they're tied in that example. So I just wanted to show you that to kind of, illustrate how this question works. Okay, so now they're basically saying, we're giving you the first 2. Austin is given 2 and Joshua is given 3. Then what's the scenarios here? Okay, so we can do that. So Austin goes first, right? Then Joshua, then Austin, then Joshua, then Austin. Okay, so it's always 2, 3. All right. And then we just have to figure out the scenarios, I guess. Yeah, so since the numbers are 1, 2, 3, 4, and 5, and 2 and 3 have already been selected, we have to select 1, 4, and 5. So what are the possibilities? You can have 1, 4, 5, or you can have 1, 5, 4, or you can have 4 and then 1, 5, and then 4 and then 5, 1, like that. And then you can have 5 and then 1, 4, and then 5 and then 4, 1. And I think that exhausts all possibilities. So that's 6 possibilities, correct? Yes. Okay. So then we just have to manually sort of figure out the final scores here. And then who is the winner. Okay. All right, so let's figure this out. And we, I guess, have to do this manually. It's just time consuming, that's all. The actual mathematics is very straightforward, and it's just adding numbers. Okay, so the scores. This will be 6, right? 2 times 3. This score would be 3 times 1. This score would be 4 times 1. And this score would be 20, 4 times 5. So then for Austin, it would be 3 and 23 as 3 and 20, which is 23 as a total score. And for Joshua, the score would be 6 and 4, which is 10. So the winner here is Austin. Got it? And then pretty much you're going to do the same for everything else, and I'm certain you can. So I don't need to talk you through it. I'll just fill in the numbers. And you guys can definitely do that on your own to verify that these numbers are correct. And the winner looks like Austin, Austin, Joshua, Austin, and Joshua. So the probability of Austin winning looks like 4 of the 6. So 2/3 in lowest terms. A sphere and cone have the same volume. The area of the lateral surface of the cone is 80 pi, and the total surface area of the cone is 144 pi. Determine the radius of the sphere. A volume of the surface of the cone, they've been very nice and given us. And the volume of the cone, I believe they've also given us 1/3 pi r squared h. And they also have been very nice to explain something. Let me just draw a cone first. This is the center, let's say. So if this is the radius, this guy right here, this is the radius, that blue part, and then this is the height, this is the slant, this from here to here. And they're saying, what are they saying here? The lateral surface area of a cone is pi rs. So the lateral surface area. Okay, so not including the top, not including that top circle. I guess that would just be pi r squared. All right, so with all that information, we've got to figure out the radius of the sphere. So that's this big R that I've denoted, big R. All right, so let's see, where can we begin here? This piece of information, 80 pi, let's start there. That is the lateral surface of the cone. And they've told us that that is pi rs. Okay, so 80 is rs. And that means, did they give us anything else? There's 2 variables here. Well, not yet. I guess I have to figure it out. So, but they did give me this, the total surface area of the cone. Okay, that's good, 144 pi. And that's basically, and I think I just touched on it, the lateral surface area, which is pi rs, plus the top surface area, which is that circle, which would be pi r squared. Okay, I think that will help. So the pi's go, so this is just 144 is rs plus r squared. Now rs is 80, so that helps. 80 plus r squared. So that means r squared would be 64. Oh, okay, so r is 8. Okay, that's great. So then I can go back to here, plug in that 8 for r, and that would mean s is 10. All right, great. So those 2 pieces of information are very helpful. And then I can, with this triangle, since it's a Pythagorean relationship, it would be r squared plus a squared is s squared. And since I have my s and r, I can figure out h. So that would be 8 squared plus h squared is 10 squared. So solving this, we'll get h equal to 6, I believe. All right, so, but I still haven't figured out this big R because I think that's the next part. Oh yeah, a sphere and a cone have the same volume. Okay, that's how we're going to figure out R. So the cone and the sphere have the same volume. So that basically means that this is the same as that in this particular case. So 4/3 pi big R cubed is equal to 1/3 pi small r squared times h. All right, so I think I just plug it all in and solve for the big R. So the pi's go, so this, and the 1/3 go, so this is just going to be 4r cubed is r squared, 8 squared times h, which is 6. Yeah. Okay, so r cubed looks like 64 divided by 4, which is 16, and 16 times 6, which would be 96. And therefore r would just be the cube root of that. And we are completed the question. Determine the value of the following sum. Note that the sum includes a total of 10 terms. We are going to use some log rules, and fortunately, none of them more complicated ones. I think the only one that I can initially see is the one that says that if you have log of something to the base a plus the log of another number to the base, same base, or same base? Yeah, same base. Then it would just be log of m times n all to that base. So I think that's the only log rule. And then maybe some basic ones that are very intuitive. Okay, let's see what happens here. So this is log. Well, first let me just add these, well, not add, but do these fractions, these subtractions. 14 over 15 for that guy. And they're all log to the base 3. That's 13 over 14, base 3. And so on, log of 12 over 13, base 3. And then it kind of just keeps going like that. Base 3, 7 over 8. 6 over 7. And I think there's one last one. 5 over 6. Okay, so then if we use this rule, this will be log to the base 3 of 14 over 15 times 13 over 14 times 12 over 13 times, and you guys get the point, all the way to 7 over 8 times 6 over 7 times 5 over 6. So you'll notice when you do this, this 14 cancels with that. That 13 will cancel with that. That 12 will cancel with that. That 7 cancels with that 7. 6 cancels with that 6. This 8 will cancel with the 8 over there. So the only thing you'll be left with is this 5 and this 15 to the base 3. And that's pretty much what this all boils down to. Pretty nice, right? So that means this is 1 over 3rd to the base 3. And then 1 over 3rd, I believe, is 3 to the power of negative 1. And then you can put that negative 1 out front using basic log rules. And then this is just 1. And then, therefore, the final answer is negative 1. A log has a combination that is a 4-digit positive integer. The first digit is 4, and the 4-digit combination is divisible by 45. How many different possible combinations are there? All right, let's see what we can get here. So the first digit is a 4, and the next two we don't know, and the last, it's divisible by 45, right? So if it's divisible by 45, that means it's divisible by 9, and it's also divisible by 5, right? Yeah, that's the only way a number can be divisible by 45. It's divisible by both 5 and 9. If it's divisible by 5, then that means that its units digit, its last digit, is either 0 or 5. And that's it. There's no other possibility. Okay, so that means that this 4-digit number is of the form 4xy0, 0, or it's of the form 4xy5. And I think that's it. Yeah. Okay. Well, I guess we just have to manually go through these now. So a little time consuming, but shouldn't be too bad. So first let's deal with that guy. The 4xy0. Okay, so we took care of this divisibility rule. That allows us to get the units digit. But this divisibility rule we need to solve, or not solve, but to utilize. If something is divisible by 9, that means that the sum of the digits is divisible by 9. Sum of the digits is divisible by 9. So in this case, that would be 4 plus x plus y. And it's going to be some multiple of 9. So either 9 or 18. And let's see, if are these different digits or the same digits? Doesn't say. Does it say? A log has a combination that is a 4-digit positive unit. The first digit is 4, and the 4-digit combination is divisible. It doesn't say. It could be the same. Like x and y could be the same, perhaps. Well, it doesn't really matter. I'm just trying to think what's the maximum. If both of them are 9s, which is the largest single digit, it would be 9 plus 9 plus 4, which is 22. So we don't need to worry about the 27 multiple. So I think these two are the only ones. This one gives me x plus y is 5, and this one gives me x plus y is 14. So with those, I just have to now manually create the ordered pairs, I guess. So for this one, it would be 0, 5 for x and y. 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, and 5, 0. Okay, so that's 1, 2, 3, 4, 5, 6. So I got 6. For this one, let's see here. 5, 9, 6, 8, 7, 7. So see, there is a possibility that both an x and y can be the same number. Not that it's that important. I was just a bit curious as if it was possible. And then 9, 5. So this gives me 1, 2, 3, 4, 5. So 5 of these guys. Okay, so a total of 11. So 11, we got 11 for this scenario here. Okay, let's go to the next scenario, which was 4, x, y, and 5. For that one, same story, divisibility rules. The sum of the digits has to be divisible by 9. So that means in this case, it's 4 plus 5, which is 9 plus x plus y, is either 9 or 18. And can it be 27? Let me think about this. Oh, I think you can make it 27. Okay, so it looks like this one might be a few more than the other one, or who knows. So 9 plus x plus y is 18, or 9 plus x plus y is 27. So this basically means that x plus y is 0, and the only scenario there is 0, 0. This one means x plus y is 9. So that means you have 0, 9, 1, 8, and so on, all the way till 9, 0. And then this one means that x plus y is 18, and the only way to get that is 9, 9. So this is one, that's 10 of those guys, and this is 1. So a total of 12 there. So the grand total is that 11 plus that 12. So 23 different scenarios that meet the criteria of the question. If a regular n-gon, A1, A2, A3, all the way to AN, where n is greater than 6, and sides A1, A2, and A5, A4 are extended to meet at point P, if angle A2P and A4 is 120, determine the value of n. Well, let's, how do I approach this? So let's put a little a dot in the center of this n-gon, and let's join these to that dot. So this guy, and so on. So that, and that, like that. Okay, now this diagram has already become kind of crowded. So I don't think I can squeeze in the numbers here. I'm going to have to draw a little bit on the side here. Let's see. I'm going to have to exaggerate it so I can fit in. Yeah. Okay, so now let me see if I can do this here. Yeah, like that. And then, oh boy. Yeah, that's good enough, I think. And then I'll just manually kind of join these. Yeah, so I just drawn the same thing, and let me just label this. So this guy is A1, this is A2, that's my A3, A3. That's A4, and that's A5. Okay. Now, since these are basically isosceles triangles, where this is the same as that, I'm just going to call that and that the same, because that's a property of an isosceles triangle. Those angles would be the same. We'll just call it A. And these are identical isosceles triangles, so these are all going to be A's. A and A. Okay. Let's see, where do I go next here? Oh, they've given me one. A2P, A4. A2P, A4. So this is 120 in there. Okay, that helps. Yeah, I think that helps. And then if I were to join that guy, then that means that that angle in there would be 60, and that angle in there would be 60. And then this angle is A, so this little guy in there would be what? Is there some correlation there? Yeah, there is, because since this is also A, that little guy would be 180 minus 2A. Yeah, so this angle in here would be 180 minus 2A. And therefore, let's see here. This angle, that angle, would be 60 plus 180 minus 2A. Would be 180 minus those two guys, right? So that's going to be, let's see here. And I think that comes out to 2A minus 60. Or another way to think about it is, if this little guy in here is A, then that one would be 180 minus A. So if you were to cut that, this is 60 and that's 180 minus A. Let me just draw that here. So this was 60. This is 180 minus A, and that is 180 minus 2A. All right, so a little bit of angle chasing there. Okay, so now we need this guy in here, these little guys, and that is 360 divided by n, because all the way around is 360 and there's n of them, so each of them will be 360 divided by n, because it's an n-gon. Okay, so I think I put the pieces of the puzzle together. Now I have to figure out what is A, and then eventually I have to figure out what is n. So if you just look at this triangle, that's going to be A plus 360 divided by n is 180, correct? So, okay. So that means if I divide through by 2, it'll be A plus 180 over n is 90. So A is 90 minus 180 over n. Okay, still haven't figured out any of these. I have to figure out A probably. So let's use this. Yeah, let's use this triangle. Hopefully I can figure out A. So the sum of the angles of that are 180, of course. So 180 minus 2A plus 60 plus 180 minus A. That all will equal 180. So this will be, that cancels with that. So this will be 240 is 3A, and therefore A is 80. Okay, great. So I finally got a value, and then I guess I can just substitute that into there to figure out n. So if A is 80, that means 80 would be 90 minus 180 over n. So that means 180 over n is 10, and therefore that would mean that n is equal to 18. There are 21 marbles in a bag. The number of each color of marble is shown in the following table. For example, the bag contains 4 ecru marbles. 3 marbles are randomly drawn from the bag without replacement. The probability that all 3 of these marbles are the same color can be written as 1 over k. What is the value of k? Well, like any probability question, you're going to have a fraction, and the bottom number is the total, and the top number is our specific condition. So let's talk about first, what is the total? The total is just going to be, how many marbles do we have in total here? 21, right? Yeah. So the total is just from 21, you choose 3 without any conditions. So that is 21 times 20 times 19 over 3 times 2. So that's looks like 7 times 10 times 19. So that's going to be in the bottom denominator. Okay, so the numerator is a little bit more complicated. That's the specific condition. So a specific condition is that when you do choose 3 marbles, that they all end up being the same color. All right, so let's see here. For magenta, that's not possible since there's only one magenta. For puce, that's not possible, so the probability there is 0. But for cyan, I think it's possible, and there's only one way that you can do that is if you were to choose. Let me think about this. Yeah, if you're just to choose all 3, there's only one way that can happen. Now, for ecru, it would be from those 4, you'd choose 3, and that will give you 4 possible ways. Like if these marbles were like labeled, like this is ecru 1, ecru 2, ecru 3, ecru 4, and you wanted to choose 3 of them, that 4 ways that can happen. It could be either like E1, E2, E3, E1, E2, E4. You see what I'm saying? And there's 4 ways of doing that. I just listed 2. For aquamarine, from the 5, you choose 3, and that is equal to 10. And for lavender, from the 6, you choose 3, and that is equal to 20. So it looks to me like you just add up these numbers for the specific condition. So that's going to be 1 plus 4 plus 10 plus 20. So this all math is 35 over, 70 and 19. So that looks like 1 over 2 times 19. So that's 1 over 38. And they're saying that's equivalent to 1 over k. So that means that k is 38. For each real number x, f at x is defined to be the minimum of the values 2x plus 3, 3x minus 2, and 25 minus x. What is the maximum value of f at x? Well, the way to approach this question is to graph these 3 lines. So we've got y is equal to 2x plus 3, y is equal to 3x minus 2, and y is equal to 25 minus x. So let's graph them on the same plot, and let's then discuss. And there we are. These are the 3 lines. As you can see, they're labeled. And so what are we really being asked here? We're saying at any point, what is the maximum of these 3 lines? Well, actually, that's not what we're being asked. Let me explain it a little bit better. We're basically being asked, first look at the definition, right? F at x is defined as the minimum. So at any point, we have to first look at the minimum. And then once you looked at all the minimums of those values, what is the maximum? Okay, so let's just start off with the definition. So let's start off out here, way out here. So some value of x, maybe it's minus 1. Here we have the graph of y is equal to 25 minus x. Here we have the graph of y is equal to 2x plus 3. And here we have the graph of y is equal to 3x minus 2. Now, of those 3, which is the minimum? Well, the minimum is this guy, the 3x minus 2. So you would then, if it was negative 1, we would plug it into 3x minus 2. And therefore, that would be my f at x. So it would be 3 times negative 1 minus 2, which is minus 3 minus 2. So y is minus 5. So f at x in this case would be negative 5, since it's the minimum of those three. And similarly, you do that for everything. And this heavy red line describes what f at x is. At any point, what is the minimum? And of all of those, what is the maximum? And that is this guy right here, as you can clearly tell, that point right there. So we have to figure out what is that point, and that shouldn't be too hard. I think it's just the intersection, right? So if it's the intersection, it should be fairly straightforward. So that looks to me that that point is the intersection of the lines 25 minus x and the lines 2x plus 3. So first let's solve for x. So that means 22 is equal to 3x. So x is equal to 22 over 3. And then we have to figure out f at x. And f at x in this case would be f at 22 over 3. And we would plug it into either this guy or that guy. It doesn't really matter. So if we plug into this one, it would be 2 times 22 over 3 plus 3. And that looks to me like 53 over 3. So that is the answer to this question. In the diagram, triangle ABC is right angled at C. Point D is on AC, so that angle ABC is equal to 2 times the angle of DBC. If DC is 1 and BD is 3, determine the length AD. ABC is 2 times DBC. So if that's theta, then that means that's theta also, just based on their definition. And then DC is 1 and BD is 3. Okay. Using Pythagoras, you can easily figure out that BC is root 8, and I'll let you do that since Pythagorean theorem has been done a million times. And I think we're going to use trigonometry here. So the sine of theta looks to me like 1 over 3. And you can use your calculator and figure out the angle approximately. And then we are trying to figure out AD, right? So I'm going to use, let's see here. I first have to label AD as x. So I'm going to use tan. So tan of 2 theta would be x plus 1 over that root 8. Yeah, so I can then put it in. Plug in that into the tan part, and that's going to be the tan of 2 times that. So the tan of 38 something. And when you do that in your calculator, it's like 0.8, whatever. And then now you just solve for this. And then when you solve for that, you will get 9 over 7 as the exact value for AD. A group of cows and horses are randomly divided into 2 equal rows. Each animal in one row is directly opposite an animal in the other row. If 75 of the animals are horses and the number of cows opposite cows is 10 more than the number of horses opposite horses, determine the total number of animals in the group. So we have R1 and we have R2. And we've got some sort of an arrangement of animals. Not entirely sure. Let me just try to figure this out first. So, like for example, if we had a horse opposite a horse, or if we had a cow opposite a cow, or you can have a horse opposite a cow, or you can have a cow opposite a horse, and so on. So the number of these I will denote as X, Y, Z, X, Y, W, Z, whatever, like that. Okay. So, yeah, I think that's a pretty decent start. Okay, so now let's interpret what they've told me. 75% of these are horses. Okay, so let me just write that down. Horses is 75. Number of cows, they don't tell me. But they do tell me that the number of cows opposite cows, which I've denoted as W, is 10 more than the number of horses opposite horses. Horses opposite horses I've denoted as Z. So that means that W is equal to Z plus 10. Okay. All right. Yeah, okay, that's about as far as I can go there. So, let's see here. We're going to have to talk about this in terms of rows, right? So these letters really only correspond to row 2. And row 1, we're not really sure here. So I'm just going to call the number of horses in row 1 H and the number of cows in row 1 C. Whereas in row 2, the number of horses that are opposite a horse is Z. The number of cows opposite a cow is a W. And the number of cows opposite a horse are denoted by Y. And the number of horses opposite a cow are denoted by X. Does that make sense? Hopefully. Yeah, and the total number of horses is 75. So this actually should be the total, which would be this H plus this Z plus that X. Yeah. So just going to make sure we divide it into rows. And then we got this guy here. So 75 H and X, H plus X plus Z. Okay. And then the total number of animals, well, let's just call it T, would be this H plus this C, and then plus this Z, W, Y, and X. So plus W plus X plus Y plus Z. And are there any other equations we can create? Let me think about this. I think the only other equations is to equate row 1 with row 2. Like in row 1, all the horses are denoted by H. But each of those horses, right, is opposite either a horse or a C. Now the horses that are opposite horses are called Z. The number of horses opposite a cow is denoted by Y. So that means that the H up here is equal to Y plus Z. It would match. See, it matches one by one. And similarly, this C denotes the number of cows in row 1, and the number of cows opposite a cow in row 2 is denoted by W, and the number of horses opposite a cow is denoted by X. So that means that the C would be equal to W plus X, since it matches. Okay, I think that would do it. That would give us enough information to solve for T, which is the total number of animals. There's a little bit of, not necessarily very fancy algebra, but a little bit of fiddling around with this. So let's see here. So the C, I'll use the W plus X. This H I'll just keep as H. This W plus X I'll keep as W plus X. And this Y plus Z I'll put the H. What that does is allow me to group things together. As you can see now, this is 2H plus W plus X. And then now we can use this guy here, because W is Z plus 10, right? So this W, we can put Z plus 10 and then kick out the 10, so that becomes 20 plus 2 times h plus z plus x. And then this h plus z plus x is 75, so then substitute it in there. So 20 plus 2 times 75. So that'd be 150 plus 20, which is 170. So there you go. So 170 is the total number of horses. Total number of animals, sorry. 3 circles, each with radius 1, are placed such that each circle touches the other 2 circles, but none of the circles overlap. What is the exact value of the radius of the smallest circle that will enclose all 3 circles? So in a very crude way, let me just draw this. Something like this, right? And then we want the largest circle, or what do we want? The smallest circle that encompasses all 3 of these guys. So something like this. Okay. I'm going to draw centers, and then I'm going to connect them. And what are we trying to figure out here? Let's draw the center of the big circle, and that's going to connect. So we're really look at that line. So this is the center of the big circle from that point all the way to the end. That is what we're looking for. Now, from this point here to there, that's just the radius of the small circle, which is 1. So therefore, I just have to find sort of this from here to here. Okay, I think I can do that. I'm going to have to draw that triangle a little bit bigger. And really what we're trying to find, I believe, is, I'll show you. You're trying to find the distance from here to here. That distance there. And then that would then be added to this 1. So the radius would be, let's just call this x, would be x plus 1. And that would be the radius of that bigger circle. Okay, well, it shouldn't be that hard. This is definitely an equilateral triangle. So that means that this is 60 degrees. So that means when you chop it in half, this would be 30 and 30. And then this is a right angle, so that means that's 60. And as you all know, the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3. Yeah, 2, 1, and root 3. Well, we know that this distance from here to here is the radius of one of the smaller circles, so that's 1. So this is 1. So that means x over 1 is the equivalent of 2 over root 3. Let's just see if I did that right. Yeah, I think so. So that's it. So then this would just be 2 over root 3 plus 1. In a hospital, there are 7 patients who need to be assigned to 3 doctors. In how many ways can the patients be assigned to the doctors so that each patient is assigned to exactly 1 doctor and each doctor assigned to at least 1 patient? Well, well, you've got 1, 2, 3, 4, 5, 6, 7, right? 7 patients, and there's 3 doctors, right? 1, 2, 3. So if you just look at the total possibilities, this patient could have 1 of 3 doctors, this patient could have 1 of 3 doctors, and so on. So the total would be, you multiply all these guys, and that would just be 3 to the power of 7. But what we want is the patients assigned in a way so that each patient is assigned to exactly 1 doctor and each doctor is assigned to at least 1 patient. So that is the equivalent of taking everything and subtracting from it at least one doctor has 0 patients. If we get rid of those, then that would be equivalent of each doctor has at least 1. Yeah. Okay, let's approach it that way. So, there's a few scenarios here. The first way is to give the same doctors to everybody. So if everybody had the guy whose name begins with the letter H, then the D doctor and the L doctor, whatever their names are, Huey, Dewey, and Louie, Dewey would have no patients and Louie would have no patients. So that's one way of doing it. And this could also be similar if you assigned the Dewey to everybody or Louie to everybody. So there's 3 scenarios there. So that is part of it. The other way is if you take the 7 patients and you assign to them just 2 of the doctors. So for example, you give them just Huey or Dewey, and Louie doesn't get any patients. So either Huey or Dewey, that kind of thing. Right? You guys get the point. So Louis has been left out, so he has 0 patients. Like that. So this is 2 doctors, 2, 2, 2, 2, 2. So this is 2 to the power of 7. And similarly, you could do that with H and L, where you leave out Dewey. And you can leave out Huey and just have Dewey and Louis. That would be 2 to the power of 7 also. But the problem with this is that we've overcounted. We've overcounted because from this guy, for example, we have to subtract this scenario and this scenario. So we've overcounted, so we have to subtract those 2. Similarly, you have to subtract 2 from that and 2 from that. And I think that totals everything there. So this would be 3 to the power 7 minus these scenarios. So this 3 plus these guys. So 2 to the power of 7 minus 2, and then there's 3 of them. Yeah, I think that's it. 3 to the power of 7, which is the total, minus those 3. And then those 2 to the power of 7 minus 2 is there's 3 of them. Yeah, okay. So let's do this math. So 2187 minus 3 times 126. And when you crunch out those numbers, you get 1806. Suppose that a is a positive integer with a greater than 1, and determine a closed form expression in terms of a equal to 1 plus 3 over a plus 5 over a squared plus 7 over a to the power 3. Continued. Let's call that S. So that's 3 over a, 5 over a squared, 7 over a to the power 3rd, and so on. And they've given you an expression for each of these guys. How did they actually get it? It's 2k minus 1 over a to the power of k minus 1. Now, if we multiply through by a, then this becomes a, this becomes 3, 5 over a, 7 over a squared, and so on. But let's just put in one more, 9 over a to the power of 3 it would be. And then we're going to subtract these. So this side will be as minus s. And this, if you subtract it, you'll notice it'll be a. And then the 3 minus 1 is 2. And then these guys have the same common denominator. So it would be 2 over a. Again, common denominator, 2 over a to the power of 2. And so on. 2 over a to the power of 3. And it would go on like that. Now, at this point, I think these terms have a common ratio. This guy kind of is all by itself. So we'll concentrate on those terms. Those terms have a common ratio of, I think, 1 over a. Yeah. So let's just, yeah, because you just take one of those and divide by the other one before it, and this would be 1 over a. Now, so the ratio is 1 over a, and an infinite series has a sum of a over 1 minus r, where a is the first term. So in this infinite series, the first term is 2, and the ratio is 1 over a, like I figured out there. So you do this math, and when you crunch out these numbers, you'll get 2a over a minus 1. So that means that this is 2a over a minus 1. And then, of course, don't forget about that a, and this is as minus s. Okay, but we just want s. Okay, no problem. I'll just continue here, or I can continue down here. Let's bring this down there. So factor out the s, and that would be a minus 1, and this would be a plus 2a over a minus 1. And now you just do this algebra here. That's pretty much all you're going to be doing at this point. So yeah, you can divide through by a minus 1. So this will be a over a minus 1, and this will be 2a over a minus 1 times a minus 1, like that. And then to get a common denominator, multiply top and bottom here by a minus 1. So this will be a squared minus a plus 2a all over a minus 1 squared. And that is going to be a squared plus a all over a minus 1 squared. And that is the closed form that they're looking for. In the diagram, a rectangular prism A, B, C, D, E, F, G, H has AB equal to 2A, AD equal to 2B, AF equal to 2C for some A, B, C greater than 0. M is the center of the face E, F, G, H, and P is a point on the infinite line passing through AM. Determine the minimum possible length of the line segment CP in terms of A, B, and C. So we will need to label this. So let me label, well, a lot of it is already labeled here. And let me just draw on the side here. So AB is 2A. Avoid making the diagram too messy. AD is 2B. And AF is 2C. Okay. So we have to, well, CP is already drawn, so I don't want to draw it again. But I will connect C to M. I think that should be a good line to draw. And anything else? C to A, I think that'll help us in some way eventually. I think that should be it. I don't want to draw too many lines here. Okay, so now let's talk about this. CP is important because CP is the minimum distance from C to P. Yeah, and that's what they want, right? The minimum possible length of the line segment CP. Okay, so the minimum possible length happens if C to P is a line that's perpendicular. So CP has to be perpendicular to AM. Now I know it doesn't look that way, but that's what it has to be in order for it to be the minimum. Okay? So even though it doesn't look like that, I'm going to put a little right angle there. Like that. You guys understand the right angle symbol. That's the way it becomes minimum. Okay, so now we have to use these guys here somehow. And let's concentrate on the triangle AMC. AMC. Now, AMC, that triangle's area would be 1/2 base times height. So we could use couple methods of figuring this out. The first way would be if we have AC as the base and the top to bottom distance from M all the way to the bottom, and that actually I believe is 2C. The top to bottom distance is the same as AF, which is 2C. Yeah. So this basically is AC times that letter C. Another way of figuring out the area is 1/2 base times height, but this time using the base as AM and the height as CP, because that's the perpendicular height for that orientation. So that basically means that if you equate them, AC times C is the same as AM times CP. Correct? Or actually, yeah, I got to make sure I put in that 1/2. Yeah, and then if I isolate for CP, it would be 2AC times C all over AM would be my CP. And I think, yeah, that's right. Okay, but I still have all these, I have AC and AM. Do they want what do they want the answer? In terms, okay. In terms of A, B, and C, because we have no numbers here. So I've got to get this in terms of A, B, and C. So right now I have this A, C, and AM. Obviously, I've got to get those in terms of A, B, and C, and then I should be able to put this all in. Okay. Well, AC and AM shouldn't be that hard to figure out. Let's just see here. AC and AM, right? Okay, well, AC is the easiest one, I think, because AB is 2A, right? And then BC, AB, AD is the same as BC, so that's going to be 2B. So AC, using Pythagoras, would be 2A squared plus 2B squared. Yeah, so that's fairly straightforward. So that means AC would be 4A squared plus 4B squared all under the square root sign. So that's going to be 2A squared plus B squared under the square root. Yeah. And then AM, that one, well, how do I do that? AM, let me think about this. Okay. I think I know. You just drop it down and then use that as Pythagoras right there. So AM squared would be the top to bottom distance, which is the same as AF, which is 2C squared. And then from here to here, it looks to me like it's going to be the half of AC. So if this is AC, half of that, so A squared plus B squared under the square root sign, and then all squared. Okay, so that means AM would be 4C squared plus A squared plus B squared, all under the square root sign. Yes. Okay, so we got everything. Let's just plug it in now. So this is going to be 2 times AC, which is 2A squared plus B squared, and then times just that lone C. And then AM, which is the square root of A squared plus B squared plus 4C squared. And that's CP. And I think that's it. And then we can clean this up a little bit. You can write this as 4C A squared plus B squared all over the square root of A squared plus B squared plus 4C squared. And that's CP.